And we're back. All right, so let's get into Sage. This is Life After Calculus Day 5. Whoops, I don't want to do that. I want to do Sage. Ta-da! Yes, I know, whatever. Life After Calculus 2012. Yeah. It's easy to organize classes that way. Yeah. No, I used to put it all in one big fat huge login. It's a mess, especially when you're sharing a lot of stuff. Oh, God. Alrighty, so where are we? We're over here. And let's see, we're missing George. We got Brett and Lucas and Julie. We got Phil and Jared and Matt. We're missing Kyle. Are we? Oh, Kyle's over there. Okay. Okay. And we're missing Sarah. We got Kenny. We got Dan. We got Luke. We got Chris. We got Greg. We got Graham. We got Kamari over there. We got Jay. Okay. All right. So where do we leave off? I think we're on. Did we get 2B working? Yes. 2B's done. All right. So let's do 3B. All right. Everyone done with 2B? Yours didn't work. Okay. I would print it, except the printing is down for some reason today. Something wrong with the network. Oh, there he is. All righty. All right. So let's do 3B. Now, remember 3B is based on 3A, and this is 3A. This is the logistic solution curves, right? All right, so let's do that. Let's go to 3B. So 1B is done, 2B is done, 3B.
Yeah, mine's being a little troublesome.
All right, 3B, we're still doing variable separable just for warm-up. Wait until we get into the real stuff. And I think what we plotted was, let's just double check what 3A says. 3A says we're plotting this. Okay. So we're still doing that here, but we're going to plot some solution curves on top of the slope field. So to get a solution curve, we need an initial condition. How about the initial population of wombats is, I don't know, 200 wombats. Mongoose, sorry. I said wombats. Standard units, wombats. 10 wombats is 1 mongoose, okay? So what? It's a standard unit if it has a conversion factor. Okay, 15, fine. All right. Yeah, but you can convert. All right, so let's see, is that what we did? That's 3B. All right, so let's solve. All right, so let's do a DE solve. Let's show the DE solve of, what did I do? Solve. Yeah, that's the Latin version of Sage, sorry. All right, so we're doing the, well, you tell me, how do I write this? Very carefully. Remember, DE solve wants this side set equal to 0, so we're going to subtract, right? So I got to write this first. How do you write the derivative? Yeah, how do you write it in Sage, remember? No. Diff, right. Diff of what? Y. Well, I'm not there yet. I'm just here. I'm going to say this minus this equals 0, right? So I'm here first. So the derivative of, well, y, and let's make it easy. We're going to graph with respect to x. So y with respect to x, because I think the slope field did with respect to x, comma what? 1, because it's the first derivative. That's optional, but I'm just making the point. You could write this and get the same thing, but if I'm just making the point so that when we do second derivatives, it's not optional. We know how to do it. Okay, then minus let's say, what is it, 0.01 times y times 100 minus y. Okay. Now we're going to solve that with respect to y. We want to get y, right? Let's see what you get. Oh, what do I do? Oh, yeah, I need a close for the diff. I did. I need a close for the DE solve. I need a close for the show. I always do that. Oh, I need to var y. Well, I have var y somewhere else, so I'm just going to reevaluate the whole thingy. Evaluate everything. Yeah, that's just wrong.
Yeah, I'm having the same issue.
Yeah? Okay.
It takes a while.
It takes a while sometimes. Give it a sec. All right, did you get this? Got it? No? Okay, well, all right, who's stuck? Is it an error or is it just slow? Yeah, var y, that's just because it doesn't see the var y
I tried to
from before. You
evaluate
did, really?
Yeah.
That's strange. Let me just see that. That usually does it. Unless you want to write another var y there, I guess you could do that.
And now match me.
And I just touched it, that's all I did. Okay. And yeah, did you reevaluate the whole worksheet so you can get the var y from here? Then it should show up everywhere. There it is. Good. That's it. All right. Who didn't get what I got? That means you're stuck. What happened here? It doesn't know that y is a function, right? And it doesn't know that y is a variable. So we have to reevaluate the cells that say that. Var y, right? And y, right? You got it's missing this. It's missing this. So we just reevaluate everything. All right. So there it is. Perfect.
Something wrong when you scroll out.
Yeah, I know. Let's focus on 3 for today, okay? All right. You got it? No? Oh, God, what happened? Wait, this is 2 or 3?
This is 3B
Okay, why did you call it 2C?
because the others were 2B.
Oh, okay. Oh, okay, all right. 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 What's it saying? You can't plot? Oh, you're plotting already. Yeah, we're not ready to plot yet. Don't plot yet. Just do the DE solve. Get the DE solve working. All right, so you got it, you got it, you got it. You got the log thing, right? Remember that log, by the way, what base is that log? That's an ln, really. Yeah, when it does this, it's just being stupid. Reevaluate the whole thing, did you? So that it does that again, and it does the other stuff again, like the, where is it? Like this, has to do that again. All right, so let's not worry about 2 right now. Let's focus on 3.
Okay.
All right, yeah, just focus on 3 for now. All right, you got the log? You got the log? Who didn't get the log? You got the log thingy? You got the log thingy? Yeah, good, good, good. Yeah. Ooh, amazing. All right, how'd you do? How'd you do? I want to get this to the point where I can graph it. Did you get it? Okay, good. So I got to figure out that constant of integration right there, the plus c, right? And I got to somehow get y alone so I can graph it with a plot command. Ooh, this is complicated, this one. Yeah. No, it's not?
Just not now.
All right, so let's say I did y of 0 is 200 because that's in the slope field, is it, in 3A? 3A includes 200, doesn't it? Right, so if you start at 200, it's going to be like it looks like a cooling curve, really, if you get that one to work, right? So let's see if we can get that solution curve. How are we going to get the plus c? Which is? Well, what's missing, I think, here? Comma, initial conditions, right? How do you put bracket, right? Bracket, what? 0 and 200. Remember, that's shorthand for when x is 0, y is 200. That's all. All right, so, well, wait a minute. You know what? I don't want to put it there. I want to leave that line alone. I'm going to put another show separate. I don't want to lose that last show. So, comma, bracket, 0, comma, 200, bracket. Let's see what you get. Well, apparently it figured out that c is log 200 minus log 100. Because otherwise it's the same, isn't it? Yeah. Yeah, so c apparently is negative log 100 plus log 200. Okay, fine, whatever. How in the heck are we going to get y alone? Yeah, but you can't eat it because there's a negative in front. Let's see, what about this? All right, wait, hang on. Don't you remember how to do this? You've been doing this your whole life, right? All right, how about this? What if we simplify this a little bit? How about dot, let's see, put the, where did I put the dot simplify? Let's put a dot simplify after the DE solve. Dot simplify, let's see if that simplifies something for me. And it didn't do nothing. All right, well, logs are involved with wacky exponents, and apparently simplify radical does stuff to that, I think. Well, that's a little better. I cleaned it up a little bit, okay. All righty, now, it's a little better. All righty. What if we, wait, hang on. I got rid of that. Okay. So what I would like to do is get these to combine somehow. Because what is log of y minus log of y minus 100, really? Isn't there a way to simplify the difference of two logs? It's log of y over, isn't that how we solve this ourselves, right? Is there some way I can simplify that? Let's see. What if I call this, yeah, I want log of y over y minus 100, so then I can e to them. Then I can do the e to the stuff, right? That would be good. Yeah, but I want it to solve it for me, just in case, let's say I didn't know how to do that. What if I chain a simplify? What if I do dot simplify logs? Does that do anything? Ooh, there you go. What? Well, you typed it wrong. All righty. Now I want to e to the both sides, right? Can I e to the that? Well, can I just solve for y? You think I could solve for y now? All right, let's see. Let's take this whole mess, copy it, and then put it in a solve. Solve, open parentheses, all of that, comma, for y, comma y, close it. Can it do that? Oh, it did it. Look at that. That's nice. Is nice. Okay, so that's what I'm going to graph. Okay? So let's graph that on top of the slope field. So I'm going to call, let's see, how am I going to graph this? What if I plot that? Do a plot of that. Okay. Now, what was the window for 3A? 0 to 10 and 0 to 100, huh? Okay, so let's write that. All right, so I want to have the same window so that the two plots can go one on top of the other. So comma, x min is 10, 0, and x max is 10. Yeah, this is getting a little bit long, but all right. X max is 10.
Invalid syntax.
Really? And y min is 0, and y max was 200, I think it was? Ooh, it doesn't like that. It doesn't like that. Here? Yeah, this is all one big long line. Yeah. Hang on. Variable x not found, really? Oh, wait. All right, let's simplify this a little bit. All right, let's do this. What I want to solve, let's say I call the equation I want to graph, okay, is this. Right? All right, now, let me get rid of this for a second. What if I show that? Do I get the same solution? Show equation. It's the same thing. All right, so I don't need this show. Get rid of this show. All right, so I named what I was going to show. I called it EQ. But then it makes it easier to graph it.
Wait, what is it supposed to look like?
This. Down here. Oh, the graph? We don't have the graph yet. All right. This was in the show. This thing was in the show. Instead of showing it, I called it EQ, so I could show it and I could plot it here as just EQ, make life easier. And it still doesn't like it. Why? Why wouldn't it plot that? It doesn't like that plot. All right, what the hey? Just type it in then. What is it? It's 200 times e to the x divided by quantity 2 times e to the x minus 1. Close the denominator. There's a comma there. Let's see, can I graph it now? There it is. Okay. I don't know why it couldn't graph this directly, but I just typed it in, and there you go, it graphed. Now, didn't we say it was going to look sort of like the Newton's law of cooling starting at 200? So the slow field should match, right? So what was the trick to get the slow field on? And, right, let's call this, I'm going to call this P3B, and I'm going to call the slow field back there P3A. So let's go back to 3A. Where's 3A? There it is. Let's call that P3A, just to give it a name. And then I can, now if I run this, you're not going to see anything. But if I show it, P3A, whoops, what happened now? What happened now? Damn it. It's not doing the squirt. Why? Ugh, reevaluate. Why is it doing this? It shouldn't have to reevaluate all this stuff all the time. There it is, okay. All right, so there's P3A. I want to put it together with P3B, right? So what do? What goes right here? What goes here so I can see both? Show. There you go. Let's see if it matches the slope field nice. And pretty good. Yeah, there you go. All right, so there's your 3B.
I am not getting anything with this at all.
All right, coming around. Looks like you got it. What you got? What you got? Ooh, it looks like a constant. That's weird. Well, that's because you don't have the same window. 0 to 10. You do have the same window. Wait, what? Wait, did you solve? You called it ASTF. Okay. All right. Did you plot vector field? Oh, you're copying it?
It should be exactly the same, so it's not like it matters.
Well, why copy it when you already have it up here?
Because it didn't work that way either.
Jeez.
So I'm just
All
trying.
right. But anyway, this curve. Where's your plot for this? This thing.
That is the plot. Plot D, plot that.
Yeah, but that's not how I plotted it. When you show it, that's this, right?
Yeah.
When I plotted it,
It didn't plot.
yeah, it doesn't plot right. So don't plot that. Plot this, 200 times e to the x divided by, okay, that parenthesis you need, I don't think you needed the other one, but all right, 2 times e to the x minus 1. All right, run that. Invalid syntax y.
Because it hates us.
What did I write in my plot? That's exactly what I wrote in my plot, right?
Yes.
Comma. Oh yeah, you don't need this anymore. This, whoa, comma. Run that. That's better. Well, I don't know why it's doing that. Okay, now where's? Oh yeah, it made its own X-Men. All right, run that. All right, there's your solution curve. Now get the slope field on there.
I have the plot vector field, but that doesn't work either, it seems.
That's strange. It didn't work yesterday?
Didn't work yesterday.
It's the vector field of 1 divided by L and 0.01 times y times 100 minus y all over L. Yeah. okay, that's fine. And then this has parentheses because this is a vector. And that's the domain, that's the range. And QED,
Just doesn't work.
it's just not giving it. Yeah. All right, wait, hang on. Let's clean up stuff. Sometimes this cleans up stuff for you. So 1, 2, 3. 1, 2, not 3. Unable to simplify floating point operation. It can't do. The floating point operation is the L, I think. It's messing. The L is messing up. Why? Huh. That's a possibility, but I don't think so. Ooh. Yeah, it's not getting you your self field. That's weird. All right, you fiddle with it, see what happens. I don't know. Yeah, I know, but I can't stay here all day. You got your self field? P3A is undefined. P3A. Well, this we call this P3B. So P3B equals type P3B equals. Okay, and then P3A is, you don't have 3A. All right. All right, then don't worry about 3A for now. Just show 3B then. All right, run that. And you got what I got. Okay, good. Okay. All right, do you have the slope field? You have it? Yeah. And you have the slope field with the solution curve? Yep. Good, good, good. All right, you got sort of like a Newton's law of cooling on the slope field? Yes? What?
Didn't know really put P3A in, but I went back to set it equal to that, and I think it was working before I set it equal to that. I just put in P3A, the only change I made.
That's better, right? So then where is it down here?
I didn't put it in yet.
Okay. All right, go for it. La, 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 la. You got it? You good? You good? Okay. You good? You good? You good? What's stuck here? Yes. That doesn't show anything? Yeah, you know it does that. Let's see. That one's okay. That one's okay. You have, yeah, and you have the slope field here. Well, call it P3A. That's P3A. If you want to see it, now you got to do enter, show P3A. So it's still here. So if you run it, it should be the same as this. Run it. Well, you do this click. Okay. Oh, that's a squirt problem. Why is it doing that? Let's redo this. Ding, ding, ding. Okay, there it is. Then it should show up down here. What the heck? Why? It's showing nothing. Not even this. What is? How is that possible? There's a show here. There should be something, even if it's an error.
There's show everywhere.
Yeah, there's a whole bunch of shows. What the heck? Why isn't it doing that? Everything's okay up to here, huh?
Yeah.
It's not doing nothing. Why? All right, let's see what the problem is. Let's do this. Why don't we comment out everything but the first show? And see if the first show is okay. No. Why? Show the sub of the diff of x prime minus 0.01 y times 0 with respect to y. Right. This is a comment, so that doesn't matter. That's a comment, but that doesn't matter because it's a comment, so big deal. That's really strange. Why is it working everywhere? Oh, DE sub is working everywhere except for there. What the heck?
I'm not sure what's going on there.
That's really weird. I did that already, so that's not going to help. Right? Nothing. Okay. Maybe we have to restart the whole thing. This one, right? Oh, whoops. There you go. There's something. Ed, you lost the connection on the internet to this main server. Yeah, now it's doing that again. Dang it. That's more like it. Okay. That's interesting. I got 3 outputs with 2 shows. What the heck's going on there? What's that down sign? I did that? Okay. All right. Well, now I don't know what this none is. That's weird. All right, you got the graph, right?
Yeah.
There it is. Good. All right, who's stuck? You're stuck? You're stuck? You're stuck? Everyone's stuck! Ah!
I guess so. Yeah, no, this works.
All right. Well, wait. This is working, right?
That doesn't work and that doesn't work.
P3A is undefined. You're right. So, see it if you just name it stuff. Equals? No, just equals is enough. All right, run that. And what? Ugh, that's a squirt problem. Let me just restart everybody. Good, 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 right? Okay, then down here, you should have something going on. What? Well, where's the syntax error? Was these shows working before you did all this stuff? Yeah? Was something down here? All right, let's see where the first error comes. Let's turn this off for a second. It's not that. Let's turn this off for a second. It's not that. Let's turn this off for a second. It's not that. Let's turn this off for a second. Yeah, but it might be this. Let me turn this off for a second. And this. Let's just do that one shell. That's good. All right, get rid of that. That's good. Get rid of that. That's good. So the problem is down here somewhere. Get rid of that. It doesn't like that. Now this was just, what the hell was this? This is just this with a solve comma y, right? Yeah, it had too many parentheses. All right, so now you can show it. That's what you get. Okay. Now hopefully you graph it. So the error was there. Hopefully there's no error here, and there's no error here. And that'd be it. Done. Okay. There was just that one stupid parentheses there. Yeah, you have the same thing. I think he had too many parentheses here. Were you copying from his screen?
Yeah.
Yeah. I think he had an extra thing there. So.
It just doesn't show.
Oh, it's not, oh, that's different. For that, you got to save and quit and restart the whole damn thing, because that's the server's not responding to you for some reason. Then reevaluate everything. All right, so that's good. What happened to 2A? Oh, all right, that's good. That's good. That's good. And okay, now what? Invalid token. What? All right, we just got to figure out where the error is. Let's see. All right, let's turn this off. Let's turn this off. Let's turn this off. Let's turn this off. Let's see if those three are okay. Those three are okay. All right, so there's something wrong here, maybe. No, that one's happening. So this should be okay. That's okay. All right, so something wrong here. Yeah, what happened here? 200 times. You got to say times. Yeah. Let's try that. There's still something else. 200 times e to the x over 2 times e to the x, right? Yeah, all the times are explicit. You have to write them all out. All right, so it's happy with that, so should be able to show it. And there's a show. Good, perfect, nice. Okay. And so that's everybody? Everyone got it? Okay, that was supposed to be the easy stuff. Oh my God. It still doesn't work? All right, you have the particular solution running? Leave it at that. I'll be happy with that for now. Okay, that's tough enough right there. All right, now, this is supposed to be the easy part. Why? Because these are all variable separables that you could solve very easily, because they're all first degree, first order differential equations. What does that mean, first order? What does first order differential equation mean? No. First order differential equation means it only has a first derivative in it. And it's variable separable, so it's easy, right? Now let's kick it up a notch. Because that was easy, right? Yeah. Ouch. Usually it's 0. Except every other Tuesday if it's a full moon. A derivative of any constant is 0. You know that? Yeah, sure. Because if you graph y equals 0, it's the x-axis, right? Isn't the slope anywhere on the x-axis 0? The slope of the tangent lines? Right? Okay. All right, so this is what we're going to do. We're going to kick it up a notch. We're going to talk about second order differential equations, which we haven't done a lot with, except for UAM. Anyone know what UAM stands for? Who had Heian? Who has Heian? And you don't know what UAM is? Okay, Can I take 5 minutes, go over there and slap him? No. All right, wait. What is UAM? All right. UAM is the easy second order differential equations. Wait until they get hard. All right, here we go. Number 4. All right, let's call this 4A. Number 4A, okay? This is UAM. UAM stands for uniformly accelerated motion. In other words, your acceleration is a constant, like g due to gravity, that stuff, right? Okay? Or it could even be 0. What if your acceleration is 0? This applies too. So how about we talk about the Galilean freefall model. Alrighty? Well, it's right there in front of you, so there you go. All right, so Galileo came up with a freefall model, meaning that we're not dealing with air resistance, so the acceleration is a constant, right? But wait, we're going to throw in air resistance in a minute. Ah, that's when it gets fun. Okay. All right, so let's do this. Let's var. I'm going to do. Listen up. Shh. I'm going to do a var t, and I'm going to make y a function called y of t. Right, so this is like vertical motion, y of t. Okay, and so what is the differential equation I'm modeling here? Y double prime equals what? Equals, well, let's call it, I guess we'll call it negative g. Right, is that what we're doing? Where g is the constant of acceleration due to gravity, depending on your units. What if I say g is 32? What am I saying? Feet per second at sea level on the Earth, right? Okay, so how do we solve that differential equation? I want to solve this differential equation. dE solve what? Y double prime. How do you write y double prime? All right, diff of y comma t comma 2, right. Right, good. And remember, we're setting this equal to 0, so how do you get 0 over here? Add g, and let's say it's 32, so plus 32. Just to have something to play with. And I'm going to solve this for y. So this is the first time we're using dE solve to solve for y, given y double prime, a second order differential equation, and you get stuff. Well, let's do a show so it's pretty print. Does that sound familiar? Negative gt squared over 2 plus v0t plus y0. Does that sound familiar? Okay. No? You never solved the Galilean freefall model? We did it in class. Yes. Okay. All right, so that sounds right, except it's not in standard form. I don't know why. That's weird. All right, let's solve it for some initial conditions. How about let's do the same thing, but with initial conditions. So how many initial conditions do I need? 7, right. No. Comma, square bracket. Well, let's say if t is 0, let's say y is 10, but y prime is 100. That's what that means, right? So this means y of 0 is 10 and y prime of 0 is 100. Say feet per second, right? So you're starting 10 feet off the ground with initial velocity upward 100 feet per second. And let's see what you get now. And I meant what? I lost a parenthesis. No, what'd I do? No, I'm not solving it. I'm dE solving the same thing with initial conditions. Oh, I put the initial conditions in the wrong place. Whoops, this goes inside the other parentheses right here. Right by the y, sorry. Whoops. Ding. There you go. All right, so it's negative gt squared over 2 plus v0t plus y0. Yes? Haven't we done this before? This is not news. All righty. It's the exact same thing, just figuring out the constants, k1, k2. So let's graph that. How about we graph that? how would we plot that DE solve? Let's take the DE solve and plot it. Plot that. Well, that's not a great window because t equals 0 is when we start at y equals 10, and the slope of 100 doesn't quite look like a slope of 100. But I want to see when it hits the ground, that stuff. I want to see how high it gets. I want to see where it hits the ground. When is that? Well, let's change the window. Comma. Let's say, no, why not? Do you have this exact same stuff? All right, what I want to do is I'm graphing y versus t. This is not a trajectory, it's just how y varies over time. I want to know when I get the maximum height, what the maximum height is, when I hit the ground, right? That kind of thing. So what if I change my my domain to say x min is 0 to x max is 2 times 100 over 32. What? Why? What the freak? Traceback, what? ODE, what? I'm putting this in the wrong place again. The x min, x max, y max stuff goes after the DE solve because that's where we're graphing. Sorry. Put it here. All right, so I made my x min or t min technically 0, and my t max or x max is that. Where am I getting these numbers from? What is that? What did I select 2 times 100 over 32? Because this is a parabola, yes? How do you find the turning point of the parabola? Negative b over 2a, right? Isn't that what I'm doing? Negative b over 2a. All right, so there it is. There's the max. That's when it occurs. 2 times 100 over 32. But what is it? What is that max? It looks like about 160. We could figure that out, I suppose. Let me think about what I'm doing here. Well, because remember the quadratic formula? Negative b over 2a plus or minus the discriminant, square root of the discriminant over 2a. So negative b over 2a is the axis of symmetry. And then the plus or minus the square root of the discriminant over 2a is how far each root is to the left and to the right of the axis of symmetry. All right. Fine. Now, what if, let's see, what do I want to add to this? All right. Now, what if I now define v, what if I make v a function of t? V equals a function of t. So it's going to be v of t. In other words, the velocity. Okay? Now, I graphed the position, y. Now I want to graph the velocity, v. Okay. So, where did I put that? So let's solve for v. Now, what is the differential equation for v? Isn't this the acceleration, y double prime? Isn't v the derivative of the acceleration? Isn't this really v prime? So that's what the E solve is doing. It's separating and integrating, right? So I'm now solving this. I'm solving v prime is equal to negative g. How do you solve that? How do I get the velocity function? Let's do another DE solve. Right. All right. So where's my DE solve? So let's do a show of the DE solve of what? How do I write this in DE solve? Yeah, but it's not y right now. I called it v. All right. So diff of v comma t comma 1 first derivative, right? Don't forget I got to set it equal to 0. So plus g. Let's make that still 32 for fun. And let's see what that gives me. 32, oh wait, comma, v. I'm solving for v. All right, so there's your velocity function, c minus 32t. How do you get c? The initial conditions, right. So let's show that. Whoops. I got to copy this. And let's show, let's see, in the dE self, comma. Now remember, this is a first order differential equation, so I only have to put in the 0 and the 100. Right? This is v, so v of 0 is 100. That's what I'm saying. Does that make sense? Negative gt plus v0. Have you never seen this? All right, if we graph that, you'll see the derivative and the curve together. All right, we'll finish that off tomorrow. Let's see, I want to graph that. I want to do 2 graphs there. All right, we'll finish that off tomorrow. All right, so don't forget to save and quit at the top, so you have it tomorrow. All right. Let's see, what if I want to plot that? All right, how about, all right, I'm going to call this P1, and I'm going to plot this thing. Okay, let's plot, okay, I'm going to do dE solve. Let's call P1 equals, no, P2 equals the plot of that. Okay. Now see dE solve diff, blah, 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 and then this. And, okay, good. Now, let's graph both of them together. Show P1 plus P2. There you go. And if for fun, why don't we say, comma, what did I have here? Okay, comma, color equals red, and comma, color equals green, so you can see which is which. Well, it's pretty obvious. One's linear, one's not. And there you go. So when the green function is positive, the red function is increasing. When the green function is negative, the red function is decreasing. When the derivative of y, which is v, equals 0, you have a max. First derivative test. Ta-da! And we can actually figure out where the 0, the red thing is. The 0's here, and the max. Plug in, find the 0 here, and plug it in. But I think we're done. All right, so let's leave it at that. So they'll fill that in tomorrow, and then we're going to do number 5, non-UAM second order differential equations. Ooh, what fun. Okay, so bye-bye, YouTube.